All right, hello everybody, and welcome to this virtual session with Tutoring by Trace. I'm Trace, and today we're going to be doing a how-to video on using synthetic division. So we're just going to jump right in. What is synthetic division? Synthetic division is it's almost like a shortcut to solving division problems that involve polynomials. So, there's different ways to solving division problems with polynomials. You can use long division, but it takes a lot longer than synthetic division. And synthetic division, it doesn't require a ton of thinking. So it's a lot easier than long division. And so I think it's a great strategy to use. So there are some minor rules for synthetic division. In this video, we're only going to be working with divisors that have a coefficient of 1. It is possible to use a divisor that doesn't have a coefficient of 1, one that has a 2, a 3, -2, 4, 72, whatever. But in this video today, as a beginner to using synthetic division, we aren't going to really worry about that. All degrees lower than the highest degree must be accounted for whenever you're doing synthetic division. So what that means is if in the equation it says x cubed plus x, there's a missing x squared in there. So we have to put in a 0 or a placeholder whenever we're doing synthetic division. And in one of the two problems that we're going to use, we're going to have an example of that. So I hope you guys will better understand it when you see it. The last value is always the remainder. So whenever you're doing synthetic division, the last value, the last answer you get will always be the remainder. Again, you'll see it whenever we're actually doing it. And then the degrees go down one number when you insert the new coefficients after you add the values. So once you do synthetic division, you're going to get a bunch of different values. And whatever the highest degree is, the first value you get is going to be the coefficient for 1 degree less than the highest value. Again, all of these you'll see as we're practicing. So here's our first example. We have x cubed minus 5x squared minus 2x plus 24 times the quantity of x minus 3 to the power of -1. And over on the right-hand side, I have some steps to solve, so we're going to be going through these. So first, we want to set up the problem and make sure it is in the correct division solving form. So right now, this isn't a division problem. This is a multiplication problem. But as we see, the x minus 3 has a -1 exponent. So whenever there's a negative exponent, what we can do is we can just flip it to the bottom. We can flip it, if it's on the numerator, flip it to the denominator. If it's on the denominator, flip it to the numerator. Right now, it's in the numerator. So if we flip it to the denominator, it'll give us a positive exponent. So what we'll have is we'll have x cubed minus 5x squared minus 2x plus 24 all over x minus 3. And pardon me, there should be parentheses over the x minus 3. Just make sure you know that. So right now it's in the correct division form. So now we have our little, it's almost like an L, a sideways, backwards L sort of thing going on there. And that's like our synthetic division like table that we're going to be using. So the first step is we want to define the coefficients. So we have x cubed. The coefficient of that is 1. So we're going to bring the 1 down. So yeah, see, we bring the 1 down. Then we have -5x squared. So the coefficient of that is -5 because there's a minus sign there. We have to bring that down with it to make sure that we keep the value negative. Then what we have -2, and then we have 24. And then the last part, x minus 3, is our divisor. We're going to worry about that in a minute. So there we have it. We have -5, -2, and 24. So now we have our divisor, which is x minus 3. So on step 3 of the steps to solve, it says to find the opposite constant. Look for any empty degrees. So we're going to define the opposite constant of the divisor. Okay, so we have x minus 3, and the opposite of -3 is 3. So we're going to be dividing. So the number that's going to go on the outside of our table is 3. There we go. So, and it says look for any empty degrees. We don't have any empty degrees because we have x cubed, x squared, x, and then we have the constant. So we aren't skipping any. We aren't going from x cubed to x. We aren't going from x to the 4th to x to the 1st. So we have all the degrees are accounted for. So now we're going to drop the first value, and the first value is a 1. So we're going to pull that 1 down, and we're going to bring it to the outside of our table. And so then from here, we're going to multiply the divisor by the first coefficient. So we're going to multiply 3 and 1, you see there. And whenever you multiply 3 to 1, you get 3. So because we get 3 times 1 is 3, we're going to take that 3 and we're going to put it under the second little column of our synthetic division table. So now we have -5 plus 3, and we're adding it because 3 times 1 is a positive 3. And so whenever you get -5 plus 3, you get a -2. So now we're going to repeat that system, but we're going to multiply to the new one. So we have 3 times -2. And the reason why we're doing it is because we did it in the first column, so we're doing it in the second column, and we're just going to keep repeating this. So 3 times -2, we get -6, and we're going to move that -6 to the third column. So you have -2 minus 6 gets you a -8. Sorry about that. Yes, I changed it. So now we have 3 and -8, and we're going to multiply those together. We get -24. 24 minus 24 is 0. So I hope you guys see how I did it. You just keep multiplying the divisor by the number that you pulled down, and then whatever you get as the product, you move that to the bottom of the next table, and then you add or subtract the terms, whatever, depending on the value. And so now we have our 3 coefficients. And remember, if you go back to the rules, it said the last one is always the remainder. So we have our last value is 0. So that means that we're going to have a remainder of 0. So what we're going to do with these values, we have 1, -2, and -8. We're going to turn those into the coefficients for our equation. So our highest degree in our starting equation is 3. So because our highest degree is 3, we're going to subtract 1, and we get x cubed. So that's going to be our first term. We're going to have x cubed. And then we're just going to keep going down. We're going to keep adding the coefficients. So we have x cubed minus 2x minus 8. 8 is going to be the constant because we go from x squared, x constant, then we have a remainder of 0. So we get x squared minus 2x minus 8. So our next problem, we're going to be using synthetic division. This one's going to be a little bit trickier than the last one. So we have x to the 4th minus x cubed minus 3x squared minus 825 all over the quantity of x minus 5. Again, we're going to want to set up the problem and make sure it is in the correct division form. Check, it is. Now we want to define the coefficients. So our first coefficient is 1, our second coefficient is -1, our third coefficient is -1. But if you see here, we are missing a term. It goes x to the 4th, x to the 3rd, x to the 2nd. There's no x. It goes immediately to the constant. So because of that, what we're going to do is we're going to have to put a placeholder in there. As you see right there, we have that 0. So that 0 is going to act as a placeholder. You can't just leave out values. You have to have something there to keep its spot. Keep the seat warm for it. Or else if you don't do that, your synthetic division won't work. And so we have to do that. And then again, we want to find our opposite constant in our divisor, which is 5, because the opposite of -5 is 5. So I hope you guys see how I got that 5 and how I got all these constants. You just drop them down. Remember the 0, -225. So then from here, we're going to do the same thing. We're going to drop our first value down. So we drop the 1 down, multiply 5 times 1. We get plus 5. That's a positive 5. So you get -1 plus 5 is equal to 4. Then you're going to multiply again, 5 and 4, 20. It's almost like a stair step action because, you're going from the next one to the next one to the next column. So you have -3 plus 20 is 17. 5 times 20 is 85. 0 plus 85 is 85. 5 times 85. 5 times 85 is a positive 425. And then you get a -40. So that's how that one works. And then if you bring all that down, you drop the degree, x cubed plus 4x squared plus 17x plus 85 minus 40 over x minus 5. Write it like that because that is our remainder. Remember, the last value is always our remainder. Thank you guys for watching. Follow Tutoring by Trace on Instagram and Facebook.